Hello, Extreme! This video is about the extreme value theorem, or particularly about extrema. Extrema are a really fancy term for a maximum or a minimum. Now, there are two types. Really, they're all extrema, but then there's special extrema. Also, these two words mean the same thing, so relative and local. Depending upon the book and where you're looking, they might use one of these two terms. Same thing here, absolute and global mean the same thing, but depending upon the textbook that you're looking at, you'll see one or the other. A relative extrema is a maximum or a minimum. So all of these red points here are extrema, and they're all relative local extrema. However, every once in a while, you get a super special extrema. It is the most extreme of the extrema, and those are the absolute ones. So this is a local extrema, and it's an absolute extrema because it's the biggest one. This is a local extrema, but it's a special extrema. It is the smallest one, so it is the absolute minimum, or the absolute extrema. So let's take a look at this in action. So I've got this function, I've got its derivative, and I made the graph just to kind of like help us out so we could see what's going on. But we can do all of this without a graph. I found the critical values of 2 and -2. That would make this numerator 0. There aren't any in the denominator. That would be potential critical values, but there is no real number that we can put in here that's going to make this denominator 0. We could put 2i, but that's not a real number. It's imaginary. Then when I checked my little sign chart here, I saw that the function was increasing, then decreasing for a while, and then starts increasing again. So we know that right here, after this point, as we head towards this direction, this is kind of the end of it increasing, and after that point, it continues to go down. So this must be the highest point possible. Same thing down here. This thing goes down, and then it goes up after this point, so it never goes any lower. So these are both relative extrema, they're local extrema, and they're also absolute extrema, because no one is going to be any lower than this point, and no one's going to be any higher than this point either. So this just kind of like plays into this idea of what's going on with a function either increasing or decreasing. One vocabulary term that can be a little bit confusing is this idea of critical value and critical point. A critical value is a potential extrema. It's not a guaranteed extrema. It just has potential to be an extrema, and we want to check it to see what is going on. A critical point actually is an extrema, and we actually do get a maximum or a minimum out of that, because that's what an extrema is. It's either a maximum or a minimum, and it's actually the coordinate point of that extrema. A critical value is just that x value. So the example that we just talked about, x equals -2 and x equals 2, are critical values. They are potential extrema. Then we want to check on our graph to see that it is actually a maximum or it is actually a minimum at this point. There are other tools of calculus that we can use in order to determine if it is a maximum or a minimum using calculus, but we're not talking about that right now. What we are talking about right now is the extreme value theorem. What it states is if we have a continuous function and we have a closed interval, it's not just a function that just goes wherever and does whatever. It's a function on a closed interval. It has a start and an end. That function has both a maximum and a minimum value on that interval. So here I have a continuous function. Note that it's not differentiable everywhere. Like right here, it's not differentiable. It is continuous, but not differentiable. Same there. By the extreme value theorem, we are guaranteed that there's a maximum and a minimum value. But note, it doesn't say that there's only one maximum or there's not only one minimum. We have multiple minimum. Like these are both local minimums, but this one is the absolute minimum because it is the lowest of our low points. So we're guaranteed an absolute, but we could also get a bonus just local minimum. Same thing here with these maximums. These are both maximum points, but this is the absolute maximum. It's also a local, but it's the absolute maximum because it's the biggest of our big points. Taking a look at another little kind of caveat of the extreme value theorem, you might look at this and say, hey, wait a minute, that doesn't have a maximum nor a minimum. And you'd be right. There is no maximum there because there is no point there. There's no maximum here because there is no point there. It's just kind of this like point up there, and that doesn't really connect. That doesn't feel like a maximum, like how we know maximums work. Same thing right there. It is okay though, because the extreme value theorem does not apply here. This isn't continuous. And since it's not continuous, then the extreme value theorem does not apply. So we don't have to worry about, hey, there should be a maximum and minimum. Where is it? It's not continuous. So we're not guaranteed a maximum nor a minimum. We have neither here. In this example, again, our extreme value theorem does not apply because we're not continuous right here. Yes, we're not differentiable over here, but that doesn't really matter. We just care about that continuity for our extreme value theorem. However, we actually do still get maximum and minimum in this case. This is the biggest point around. So if that's the biggest point, that is a maximum, and that is a really low point. So that is a minimum. So we do get a maximum and a minimum at this function. That was a bad sentence, but we don't get it by the extreme value theorem. We just got lucky that there was a maximum and minimum here. That is it for our video on the extreme value theorem. Reminder that extrema are just a fancy word for the maximum or a minimum. Remember the difference between a critical value and a critical point. A critical value is a potential extrema. It's just that x value. And a critical point is an actual coordinate point where we actually have either a maximum or a minimum, where we actually have an extrema. Finally, with that extreme value theorem, if we are a continuous function, then we end on a closed interval, then we are guaranteed to have a maximum or a minimum. Thanks for watching. Hope you took some good notes, and I will see you later. Goodbye.